Good morning. I am Richard Keefe, Director of Artificial Intelligence for Remote Trading Room. This morning, I want to cover one of the major issues surrounding the development and use of artificial intelligence, and that is power consumption. The demand for AI has exploded, as you well know, in recent years due to the rapid advances in deep learning and the proliferation of data. While AI has shown remarkable achievements, it has also raised concerns about power consumption during training and inference. Inference just being a fancy word for predictions. What are these concerns? Well, first, number one, environmental concerns. Carbon footprint. Training large AI models can consume an enormous amount of energy. In fact, equivalent to the carbon emissions of 5 cars over their lifetimes. Such energy-intensive processes contribute to the carbon footprint, which is concerning for our environment. Another concern is resource depletion. As the demand for AI grows, there will be an increased demand for energy, leading to faster depletion of non-renewable energy resources. There are also economic implications. Number one, the costs. High energy consumption directly translates into higher costs for training AI models. Not all institutions, researchers, or companies can afford such extensive expenses, potentially leading to reduced innovation in the space. There are also infrastructure needs. As AI models grow in size and complexity, there is a need for more robust and energy-efficient hardware infrastructure, leading to increased investments. Scalability issues. The ever-increasing size of models like GPT-3, GPT-4, and so forth means that the power consumption will continue to rise unless alternative methods of technologies are found. This could limit the scalability of AI solutions in the long run. Accessibility and centralization. Number one, high power and computational needs might result in AI research and deployment becoming centralized in the hands of a few organizations that can afford such resources, potentially creating monopolies and stifling innovation. Secondly, emerging AI researchers, startups, or those in regions with limited resources might be at a disadvantage. There is also reduced efficiency in development. Using a lot of power is not just a problem when training AI models, it's also a problem when running or using the trained models to make predictions. High power use during predictions or inference can be especially difficult for real-time AI applications or when using AI on smartphones and other devices. If the AI uses too much power on these devices, it may not work well or at all. So high power consumption can limit how, when, and where AI can be used. Wear and tear. Continuous intensive computation can lead to quicker wear and tear of hardware components, leading to shorter lifespans and increased electronic waste. It can also inhibit research diversity. Given the cost implications of power consumption, researchers might be dissuaded from exploring diverse AI models or techniques, leading to a narrowed research scope. There are also safety and reliability concerns. In systems that need continuous AI-driven operations, like in healthcare or autonomous vehicles, any interruptions due to power constraints can lead to safety and reliability issues. To address these challenges, the AI community is actively researching more efficient training algorithms hardware accelerators, and model architectures. Techniques like knowledge distillation, pruning, and quantization are also being explored to reduce the size and power consumption of models. I will explain these approaches in a later video. The goal is to achieve a balance between the capabilities of AI and the environmental and economic costs associated with its power consumption. NVIDIA recently announced a new chip called GH200, which is designed to run artificial intelligence models and is expected to drop the costs of running large language models significantly. The GH200 has the same GPU as NVIDIA's current highest-end AI chip, the H100, but pairs it with 141 gigabytes of cutting-edge memory, as well as a 72-core ARM central processor. NVIDIA CEO Justin Wang said that this processor is designed for the scale-out of the world's data centers. NVIDIA's Hopper, also known as H100, is another workhorse chip that drives the AI models behind ChatGPT. It is almost single-handedly driving the generative AI revolution, giving large language models like those underlying ChatGPT the computing power needed to process the billions of parameters that shape their output. The H100 Tensor Core GPU is priced at $40,000 and has sparked a frenzied spending spree among tech companies and investors alike. Intel also offers its Max series data center GPUs and its specialized Gaudi line of AI chips. Gaudi comes from the 29 acquisition of a company called Habana. And while the current Gaudi 2 chips aren't as fast as NVIDIA's latest data center GPUs, they are competitive when factoring in price and performance. Overall, these new chips are expected to consume less power than previous generations for AI workloads. The exact efficiency gains remain to be quantified independently through third-party benchmarks and measurements. As the chips get deployed in real-world systems, we should get better data on their power and performance characteristics.